All right, let's go through this guy. We're supposed to find V, W, X, Y, and Z. They only gave me two numbers, and they gave me a right angle sign. Who wants to start the ball rolling? Who wants to give me a letter and what it equals? Evan.
So V.
All right.
It's going to be 70 because 70 plus 180 is 180.
Perfect. Let's just go to W. Who's got W? Lydia?
110.
110. How do we know it's 110?
Because the angle that's not 110 is the vertical of that one.
Gotcha. Because they create that straight angle. Yep. All right. So W and V would be supplements, right? Correct? Because supplementary means they equal 180. Complement equals 90. All right, cool. Let's just go across the board and do X. Sabrina.
155 degrees.
155 degrees. And why it's 155 degrees?
Because it's across from the other angle, which is I forgot the word.
Who's got the word? Who's got the word? Who's got the word, Hannah?
Vertical angle.
Vertical angles. Vertical. They're vertical, right? Straight up and down. Vertical angles. Those two things are vertical angles. And then can someone give me Y? Robin.
This is 25.
Wait, did you already give me one? Yeah. No, okay.
25.
25. And it's 25 degrees because X was 155. Once again, they form this right angle. All right, and the very last one, should probably start with that one. That was probably the easiest one, right? Amber?
That is 90 degrees.
That is 90. Well, how do we know that?
Because on the other side we see the little box. What's it? And that's.
What's it? Yeah.
I don't know what it's called.
Oh, that's fine.
And that's equal to 90 degrees. So since it's right across, it has to be the same.
Yep.
dimension.
And so does this one, and so does that one, right? Yep. Perfect. So we got them all. We got them all. All right. Let's go over really quickly homework questions. Amber.
31.
31. 31. Let's get that guy in here. All right, 31 says, a supplement of an angle is 6 times as large as a complement of the angle. Find the measure of the angle, its supplement, and its complement. I'm probably just going to find, bless you.
Thank you.
That was very silent. All right, I'm probably just going to, let me change this to red so it'll show up. Well, we're talking about complement. We're talking about its supplement. So let's come up with an angle. Let's call it angle A. You can call it X. Some people like to just put X. I like to say it's an angle. All right, its supplement. So sup, I'll just put sup to shortcut it, and then I need a comp for my complement. My supplement is always going to be 180 minus that angle. And my complement's always going to be 90 minus that angle. So realistically, anytime you read these problems, you could set this up the same every single time. Whether you use the complement, whether you use the supplement, you can just see this problem and know you need these three things. You need an angle, you need its supplement, and you need its complement. All right, supplement of an angle is 6 times as large as a complement. So now I just got to figure out which one's bigger. Which one's bigger, my supplement or my complement of the angle? Yeah, because the supplement's 6 times as large, right? So my supplement is way up here, my complement's down here. So to make them equal, I need to multiply my complement until it's as large as my supplement. So when we do our addition, we're going to say the supplement's bigger. So the supplement is going to equal, well, not quite the complement, but 6 times the complement. And then we just got to put those equations in. So my supplement was 180 minus angle A. That's going to equal 6 times my complement, which is 90 minus angle A. Then we just, did I already answer your question? Okay.
I just needed help with I wasn't sure what to do with the 6. But
Oh, gotcha. Yep. 6 has to go on the outside of these parentheses.
Yeah.
Anytime we're multiplying, it goes on the outside. Yes, Sabrina.
24 through 27, I got all the wrong answers, and I don't know why.
Oh, okay. Does anyone have questions on this one? Is this far enough for this one? Because you just got to solve for angle A and then plug it into each of these to get your. All right. So you have question. Let's just pick one of those.
Number 24.
Number 24. All right. Measure of angle A and measure of angle B are supplement. So what does that mean? Angle A and angle B add to
180.
180. So let me just. So we're doing 24, right? I'll do it underneath it. So measure of angle A plus measure of angle B must equal 180 because they're supplementary. So that means 2x plus x minus 15 equals 180. Is that what you did so far?
No, I just did, I did 2x equals x minus 15, and then I solved it as an algebra problem, and then I plugged that in.
That's not going to work. Because you have to use this fact, they're supplementary. Don't just set things equal to each other. That's the biggest thing that I notice on tests is anytime someone sees x values, they automatically put them equal to each other. If I wanted them equal to each other, I'd say the two angles are congruent or equal. Make sure you read every word. So this one says supplementary, so you should have had at least one. Supplementary tells you 180, so you should have them equal to 180. If they said complementary, it would say 90. Does that help with those? Okay. Other questions?
Did you do 32?
32. Was that on the page or is that on the next page? Let's just look at 32. So 32, find the values of x and y for each diagram. Okay. Let's go ahead and bring that guy up. All right, these kind of take a little ingenuity. Because you'll notice you can set 3x minus 8 equal to 2y minus 17, right? You might have tried that. Because they're vertical angles.
I did like x plus 3x minus 8 equals 180.
Ooh, that's a great way to start. That's a great way to start. And what did that come out to?
I got 47.
So you set that equal to 180 because they are a straight angle. That's a perfect way to start. And you came up with x equals what?
47.
X equals 47. So where'd you struggle at, I guess?
I don't know, I just got the wrong
Yeah,
answer.
me too.
Oh, did you get 47?
I got 47. I just didn't get the second part. I got 70, and it was the answer said 75 for the next part.
Oh, for y?
For a while, yeah.
Okay, so if this is 47, what does this equal?
I did like 2 out of minus 17 equals 3x minus 8 because of vertical angles.
Yeah, yeah.
And then I got,
And then you plugged in 47 for your x value?
Yep.
And it didn't work out?
yeah, I tried it a couple times too. And I got 70.
Did you multiply 3 and 47 before?
Let's just set it up. We'll see what happens. All right, so we know that 3x minus 8 is going to equal 2y minus 17 because of vertical angles. We plug that 47 in for that x, so I'd have 3 times 47 minus 8.
Oh, I did 18. That's why. I wrote it down.
Oh, okay. Did you write down 18 as well?
No.
Did you do this right so far?
Yeah.
You might have did it different. Yeah. So
Okay.
so far we're on the same.
Yeah, I just. Wait, is the answer 75 now?
Yeah.
Oh, I don't know what the answer is. Okay. Yeah.
Okay, okay. I just redid the second part and now I got 75, so I don't know
Okay.
what I was doing before.
Well, then when you solve for this, you're going to come up with y equals 75. No, that's fine. That's why we do this stuff. All right, we all clear on that one then?
Yeah.
Okay. So we find our x value by setting this equal to 180, and then we plug it into this because these are vertical angles. All right, other questions? Rita.
For number 33, I got 98 degrees.
The band? Wasn't that a band? Isn't there a band 98 degrees? No?
I don't know.
You sure? Like an old one? With Nick Lachey? With Nick Lachey? Alright, 33. You came up with the wrong answer?
Yeah.
Okay. So did you do 2x minus 16 equals 50 degrees to get your x value?
I did equals 180 degrees.
Which one equals 180?
Oh, 2x minus 16 equals 180 degrees.
Do they equal 180? What do we know about vertical angles that are across from each other?
They equal each other.
So you should have put up 2x minus 16 equals 50 degrees. Because they're vertical angles. The only time you're going to say they're equal 180 is if they form a straight angle like this. If it's two angles that form a straight angle. Or if you're adding three angles, they have to form that straight line. If they're across from each other, you have to set them equal to each other. You have to set them equal to each other. All right, other questions? Okay, then we have to start the lesson. All right, today we're going to talk about perpendicular lines. We're going to talk about perpendicular lines. Perpendicular lines, the symbol for it is just this little line. You can almost picture two right angles, right? It's like an upside down T. That is a symbol that automatically stands for, hey, these two lines are perpendicular to each other. So these are two lines that intersect to form a right angle. Or I should say right angles, which means they form 90 degrees. So a quick picture of that might be just a line. Let's give it some arrows. Let's give it some values. We'll call that A. Call this B. We'll call this N. And we'll call this M. And as soon as I put that little box around it, we know that AB, line AB, is perpendicular to MN. So, yeah.
So could you have like a line like this, and just like touching the corner but not like fully going through? Would that be considered perpendicular or no?
Well, it'll always be going through. I think I know what you mean. Let me draw a picture of what I think you mean. So you mean like I have a line going here, and then you have like a segment.
No, like this.
Oh, okay. So two segments that just form. As long as, because segments. So yeah, technically they'd be perpendicular because you could extend them as lines, which would make all the rules possible. Because you picture those two segments butting ends, but as soon as I call them a line, they go on forever in both directions. So yeah, that would still be perpendicular. Note too, if this one is 9 degrees, that means this one's 9 degrees, which means this one's 9 degrees, which means this one's 9 degrees as well. So it always forms, not form. I guess it always form. No, gotta be forms. Always forms 4 right angles. It always forms 4 right angles. So as soon as you hear perpendicular, you're going to think, oh, I need 4 right angles. All right, just some uses and definitions of perpendicular lines. There's a picture still. If JK is perpendicular to MN, written as JK is perpendicular to MN, with symbols, then each of the numbered angles is a right angle. So 1, 2, 3, and 4 are all right angles. So automatically, as soon as you read perpendicular, you're going to know all of those are right angles. So perpendicular means boom, 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 boom. Which also means as soon as you see 2 right angles and one of these boxes are drawn, all 4 of them are, and it's perpendicular.
So if it doesn't have any boxes, we can't call it
Correct.
You can't say that it has a right angle.
The only way we know for a fact they're right angles is if I give a box here, or if I say they are perpendicular to each other. Otherwise, you can't assume. It can look like it, but if they don't tell you it's perpendicular, or they don't give you this 90-degree symbol, we can't just say, well, they're perpendicular because they look that way. All right. If any one number on a numbered angle is a right angle, then, so we're going the other direction. If I tell you that one of these is 90 degrees, then we can say that they're perpendicular. So JK is perpendicular to MN. What's that saying is we can go both directions. If I say they're perpendicular, you can write all 4 of them as right angles. If I'm just given one of them, then I'm allowed to say it's perpendicular. So that's both directions of symbols versus perpendicular. Yes?
So if I said that, then you could also say, and that means that they all are right angles?
Yep. So as soon as I give you one of these symbols, you know all of them are right angles and you know they're perpendicular automatically. And if I say it's perpendicular, then you know all 4 of them are right angles. So it works both directions. You could think about that when we're using proofs later on, right? Because there might be proofs that are just like, these 2 lines are perpendicular, prove that angle 3 is a right angle. So you can kind of say, well, one's a right angle, something. You can just follow along with those rules. All right, that leads us into theorem 2.4. If 2 lines are perpendicular, then they form congruent adjacent angles. Well, that makes sense, because let's draw a picture really quick. Let's draw a quick picture of 2 lines that are perpendicular. Doom, doom. Doom, doom. Doom, doom. We'll call this guy A, B. We'll call this one M. We'll call this one N. Well, if these are perpendicular, then all 4 of them are right angles. And if all 4 of them are right angles, they're the exact size, so they must be congruent. They have to be congruent, and they're definitely adjacent to each other, because this one shares a side, these 2 share a side, the other ones share a side. So I'm going to name these really quick. 1, 2, 3, 4. So what this says is basically if line AB is perpendicular to line MN, then we just go ahead and say that angle 1 is congruent to angle 2, is congruent to angle 3, is congruent to angle 4. So all 4 of them are congruent. They're also adjacent. Can't really draw that in there.
Doesn't that mean that we can assume that they're right angles even if they don't have the box? Like, because you said because they have the other reason.
I said if
Yeah.
this is
Yeah,
true,
sorry.
then this is true. Yep.
Got it.
So we could also apply this to the fact that if my drawing had one right angle, then I would know they're all right angles as well. All right, this is a theorem that we've been using basically, because we can just work our way around. We're just more formalizing it. All right, theorem 2.5, if 2 lines form congruent adjacent angles, then the lines are perpendicular. This is just the reverse of 2.4. So what 2.4 says, if they're perpendicular, then they're all congruent. The next one says, if you have 2 intersecting lines and all of your angles are congruent, it must be perpendicular. Because the only way all 4 of these are the same size is if they're 90. Because if they're 91, 91 plus 91 would equal 182. Is a straight angle 182 degrees? No, it's not. All right, so if all 4 of these angles are the same measure, they have to be 90 degrees. That's why that theorem works in both directions. So once again, I'm just going to, it's basically we're just going to do that one in reverse. I'm going to draw that same picture. Boom, 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 boom. That's drawing music to keep you entertained. Does it work? Nice. And we got, and I'm going to call this angle 1, 2, 3, 4. Remember, if you ever just want to put numbers on an angle, that's fine. Like on a test, if you don't want to keep going A, B, C, D, E, F, G, you can just put numbers on it and say angle 1. All right, so this theorem just goes the other direction. So this one just says if angle 1 is congruent to angle 2, because they add to 180, they must be 90 degrees. So then, I have AB. AB is perpendicular to MN. And remember, that's because they have to add up to 180. And if they're congruent, they have to be 90 degrees. As long as I can prove one of them is 90 degrees, it means everything's 90 degrees, and they are perpendicular. Both those directions make sense? Basically, it just boils down to which direction we're going. If I'm given something's perpendicular, I can assume something's 90 degrees. If I'm given something's 90 degrees, I can go back and say they're perpendicular. All right, so each of these goes a different way. All right, theorem 2.6. If the exterior angles of two adjacent acute angles are perpendicular, then the angles are complementary. So we're given that OA and OC are perpendicular. And Evan, this kind of boils down to what you were asking, right? Because you can picture like these continue on, and I could form all four of those. But right now we're just focusing on this one little area. So it says if the exterior sides of two adjacent acute angles are perpendicular, then the angles are complementary. AO is perpendicular to OC. So that must mean since they're perpendicular that they form a right angle. Well, if they form a right angle, that must mean that measure of angle 1 plus measure of angle 2 equals 90 degrees. So then we know measure of angle 1 plus measure of angle 2 equals 90 degrees. Oh, that's the definition of complementary. So they have to be complementary. Well, proved it without even trying. So can you kind of see the proof that I did there? I didn't write it all out. But in short, I basically said because they're perpendicular, they form a 90-degree angle. Because they form a 90-degree angle, measure 1 plus measure 2 equals 90. Well, that must mean they're complementary because that's the definition of complementary. So I did a complete proof right there. I just didn't do it step by step by step. That's the easiest way to do step by step by step proofs, is actually kind of work your way through it and then figure out what steps you actually did to prove it. Okay? So you're just using knowledge you know to solve it, and then you put words to it in a certain way. All right, 2 quick examples, and then we'll be done. If diagram BE is perpendicular to AC and BD is perpendicular to BF, find the value of x. So we could write that information. I'm just going to write the most pertinent to this one. Because this one says ABD equals 2x minus 15, and measure of angle DBE equals x. So let me write that information in that I just said. So we said ABD equals 2x minus 15. So that's 2x minus 15 here. And then it also says DBE equals x. So this is going to be x here. But if you go back up to the definition, BE is perpendicular to AC. So how big is this angle here? How big is the angle ABE? Robin?
90 degrees.
90 degrees. So that means this angle plus this angle has to equal what? Jacob?
90.
That has to equal 90 degrees. Yeah. So this angle plus this angle has to equal 90 degrees. So we're just going to do some math. We're going to say, well, 2x minus 15 plus x must equal 90 degrees. Doing some, we have 3x equals 105. Divide both sides by 3. And we're going to have x equals 3 is 35 degrees. It doesn't ask for angles, but if we did, it wouldn't be that big of a stretch. We just plug it in for x values and we have our two angles. Questions, comments, concerns on that one? Last one. Whew. All right, this drawing gets a little complicated. This drawing gets a little complicated because we're going to put all of our perpendicular lines in there. So what I would do is, we know that this one's perpendicular there. That one creates a 90-degree angle. And I'm going to do this one a little bigger. We know that this one creates a 90-degree angle as well. And the other side creates a 90-degree angle as well. So I just kind of did 3 different sizes. Ooh, I should move this to the other page. I'll move that to the other page. So once again, I kind of just picked different sizes, all right? Because sometimes it's hard, especially if you just have a pencil, it's hard to tell which one is going where. All right, so our first thing says that measure CBF equals 40 degrees. So right here, we're talking about this is 40 degrees. I'm going to kind of do both of them at the same time. All right, I'm doing 40 degrees, and I'm going to do x along with 40 degrees. So one says it's 40 degrees. The other one says it's x. So that says find this next angle here. How do I find this next angle? How do I find angle EBF, Grace?
So since you know it's a right angle, EBF has to be 50.
Has to be 50 because of?
Because
What math did you do in your head? I mean, you just did in your head.
because right angles like 90 degrees, so you just do 90 degrees minus 50.
Yeah. So I'm just going to put that down. I know we can do it in head. I know absolutely we can do it in our head that 90 minus 50 equals, 90 minus 40. I had 50 already stuck in my head. Equals 50 degrees. And I want to do it that way because when we go to our x value, it's just going to be 90 degrees minus x, right? We good with that? So this is 50. Maybe I'll write that in. This is 50 degrees. Or for the bottom one, it is 90 minus x. All right, then we switch to the next angle. We switch to DBE. But this also forms a right angle, right? Yeah, Robin.
Wouldn't it be 40?
It would be 40. Because just like the one before, we would do 90 minus the angle before it, which was 50 degrees, which equals 40 degrees. So that one's going to equal 40. What would be the best way to write this? Let's just put it up here. 40, ooh, it's not in red. Let's put that guy in red to match the other ones. Who wants to try it with the x values? It gets a little trickier. Hannah?
90 minus x. Because, like, you have to take from the 90 minus x value, if that makes any sense.
No, that makes 100% sense.
Okay.
You actually did it 100% correct. We did 90 minus 50 because I did 90 minus the angle before it. We can do that with x values. We can just say it's 90. We're going to simplify it a bit. So I can say it's 90 degrees minus the angle before, which is 90 degrees, minus x. All right, I just took that 90 degrees and did the same thing we did up here. All right, well, 90 minus 90. Well, first of all, I got to distribute that negative sign, right? Do you see that negative sign hanging out there? So it's actually 90 minus 90 plus x. Are we okay with that? Because I distributed that negative sign. So this cancels out. I'm just left with x. So it's either 40 or it's x. But that makes sense because when it was 40 40 had to equal x. This one's 40, so it should be x. Yeah, Lydia.
What if you just recognized that it was X without doing all that?
That's fine.
Okay.
Yeah. I just want to help out people that didn't quite recognize it.
Okay.
All right, then we'll do the next angle. The next angle is just 90 minus the angle before it, which is going to equal 50 degrees. And that must mean this is 90 degrees minus x, because it's just the angle before. All right, so now we have all our values. This one is 50 degrees and 90 minus x. Yes?
Couldn't you just do for DBE, just,
We're on DBC though.
yeah, but I just have a question about the X's.
Okay. For
Um,
DBE. Okay, I'm on it. I'm on the trolley now.
Why can't you just do 90 minus X? Because like you do that in your head with like why did you do the 90, like why would it be X instead of just 90 minus X? Because I thought that was just showing what your thought process was.
It is showing my thought process. I started with this angle being x. So basically I'm saying x equals 40 degrees. My next one is 90 minus x to get this angle. And this angle here is 90 minus whatever this angle is.
Yeah.
This angle is 90 minus x. So you can't just simplify that to be x.
Okay.
It has to be 90 minus whatever this angle is. And this angle is 90 minus x. So it's 90 minus the 90 minus x.
I was just like, doing 90 minus. Okay, never mind.
It has to be this, because anytime it says 40 degrees, we should have an x value. All right, because these angles should be the exact same, and these two angles should be the exact same. And if you just would have said this was 90 minus x, you would have changed the value of x, basically. Okay, is that making more sense?
Do we have to do this just for other problems like this?
Possibly.
Oh, okay.
Just follow the pattern that it's just the angle before it, 90 minus the angle before it. So that's why I did it in this table form. All right, the angle before this one was 90 minus x, so it had to be 90 minus this angle before. All right, the last one says measure of angle DBC. Yeah, Robin.
I got 130.
For DBC, you got what?
130.
130, so you did 40 plus 40 plus 50?
I just did the 90 degree plus 40.
Nice.
Or no, yeah. Yeah, that's what I did.
What'd you do?
I took the 90 degrees EBC.
Okay, and then you added the,
40.
yeah, that works out too. So either you can add all four of these angles, because we're talking about this one, or Robin recognized this is 90 degrees, so just do 90 minus whatever this is. Which is great, because if I did 90 degrees, let's go ahead and do it that way. If I do my 90 degrees plus that small angle, that 40 degrees, that equals 130. And it's nice for the x, because that would just be 90 degrees plus whatever sliver this is, which happens to equal x. And then we got the table full. And that's it. Let me go ahead and start the homework. Homework is page 58 through 59, 1 through 17. There is one proof, I believe, in there. It's one that's already kind of filled out for you.